Today we're starting on trigonometry for the very first time. Trigonometry comes from the Greek word meaning trigonon for triangle and metron meaning measurement, meaning we still want to measure things in our triangles, and there's still going to be right angle triangles just like what we were using in Pythagoras' theorem. But unlike Pythagoras' theorem, you use two sides to find a third one. But in trigonometry, you're going to be finding both sides and angles now as well. So to do this, there's a few terms that you need to understand. The word hypotenuse, hopefully you're familiar with that one. We've been using that in Pythagoras' theorem. It is always the side straight across from your right angle, like in this drawing in here. Then we also want to label the adjacent and the opposite sides, and their location depends on where the angle theta is. Now theta is just a Greek letter that we use to symbolize the angle in our triangle. To draw it, you draw a 0 with an extra little loop in the top of it. So to label on your triangle, you find the theta, or the angle that you've been given. The side straight across from there is the opposite, and the side between the two angles, the theta and your right angle, is the adjacent. So we just want to take a couple of moments here to practice labeling our triangles. So first thing I'm going to do is I'm going to find my right angle. Straight across from that is my hypotenuse, H for hypotenuse. Then find my angle theta. Straight across from that is my opposite. And between my theta and my right angle is the adjacent. Okay, let's try the next one. Right angle is here, so straight across is the hypotenuse. Across from the theta is the opposite. And between the theta and the right angle is the adjacent. Okay, you could pause the video if you want to and try part C and D. Across from the right angle is the hypotenuse. Across from the theta is the opposite. And between the two sides is the adjacent. Okay, next one. Across from the right angle is the hypotenuse. Across from theta is opposite. And this one is adjacent. Okay, once you can label the sides of a triangle, we then want to learn about the formulas that we're going to be using in trigonometry. Now there's 3 of them. I'm going to show you all 3 to start with, but then we're going to be focusing on just one of them today. So the 3 rules are for sine, cos, and tan. Now sine theta, because it's always sine of an angle, is going to be equal to the opposite side over the hypotenuse side. Okay? The cos theta is equal to the adjacent over hypotenuse, and the tan theta is equal to opposite over adjacent. To help you remember those 3 formulas, we have a little saying here, which is SOHCAHTOA. So the first letter in each one of those syllables there is the trig function. So S is for sine, and then the O and the H means opposite over hypotenuse. C is for cos, is adjacent over hypotenuse, and T for tan is opposite over adjacent. So that's just to help you learn those 3 formulas. The next thing we want to do is learn how to use our calculators. We need to be able to type some of this stuff in. So down here in example number 1, we want to find each of the following to 4 decimal places. So you get your calculator out and you want to find your trig function. So you got sine, cos, and tan. Hopefully you can see my little cursor wiggling over the top of them there. So sine of 30, you just press the sine button and then press 30. You'll notice that your calculator opens a bracket. You can close it if you like, but it will actually answer it even if you don't close that bracket. So that's equal to 0.5. Type in the next one. Part B is cos, so type the cos button, 45 equals. So that would be 0.7071. The next one, we want tan of 20 degrees equals. So to 4 decimal places, that's 0.36. We want 39, but the 7 is going to round that up to be 3640. Part D, we want sine of 25.5 degrees. We don't need the degrees button just yet, which equals 0.4305. And E, we want cos of 72.55. That is 0.2998, but the next number is a 7, so it'll be 2999. Okay, now once you get to F, you'll notice something a little bit different. You'll see that we have 75, and then we have a degree symbol, 30, and then we have this other symbol here. Now there is actually other measurements for angles other than degrees. Degrees is the one that you've used many, many times before, but did you know there is smaller increments of degrees? Just like if we have kilometers, we have meters or centimeters or millimeters. Smaller measurements of degrees include minutes and seconds. And I know that sounds a lot like time, but that's because they work in lots of 60, just like time does. So to type these into your calculator, you still press the 10 button, you press 75, and you see this, I call it the bubble button here, degrees, minutes, seconds. It's underneath your square root sign. If you press that button, it brings up a little bubble. Then you want to press 30, and then you have to press that button again. So that is telling it that we have two different units in there, 75 degrees and 30 minutes. And then we press our equals button. So that's 3.8667. Okay, let's try that again for G. G, we have three different ones. So we have 33 degrees, 20 minutes, and 30 seconds. So we have to use the button 3 times. So sine, 33, press the button. 20, press the button again. And 30, press the button again. Equals 0.5496. And one last one, we want cos of 20 degrees, push the button, 10 minutes, push the button again. So that's 0.9387. Okay, so that was just showing you how the calculator works. Next, we want to get onto the actual formula we're trying to learn about today, which is the sine formula. We're only going to use this one, sine theta equals opposite over hypotenuse. And we're going to be using that rule to help us find sides in our triangles that you can see below here. So to start these, you always want to label your triangle first. So find that angle, not the right angle, the other one, so 45 degrees. Across from that 45 degrees is the opposite side, and across from our right angle we know is our hypotenuse. So this side over here would be our adjacent, but there's no letter or number there, so that side is not useful. So it's the opposite and hypotenuse side, which are the ones we want to use, which is the ones that are in the sine formula. So we write the sine formula down. Sine theta equals opposite over hypotenuse. So I'm just going to put O over H. Make it short as possible. Then we sub in the numbers from our diagram. The theta is our angle, it's the 45 degrees. So we go sine of 45 degrees equals, the opposite is the x, the hypotenuse is the 14. Then we need to get the x by itself. Now, if we were doing equations, we would do a little times by 14 times by 14 to get rid of that. And that means that x is by itself, and you would get 14 times by sine 45. Okay, so you'll probably find you won't write those little orange bits, the times 14 underneath bit there. You'll go straight to this next line here. Finally, you want to type that into your calculator. So it's 14 times by sine 45 equals, and we're doing one decimal place that it says in the question. That would be 9.9 because it will round up. 9.9, and that's done. Okay, so each question is going to have those 4 lines of working out. Let's try question 2. Remember, we start by labeling the triangle. So across from the 63 degrees, the x is going to be the opposite. Across from the right angle, the 19 is going to be the hypotenuse, and the 63 degrees is my theta. So we write the formula down. Sine theta equals opposite over hypotenuse. Then that's the first line. Second line, we sub into that. The theta is the 63 degrees, so sine 63 equals, the opposite is the one that has the x on it from the diagram. X over the hypotenuse is 19. Okay, the third line is to times that 19 to be with the sine 63. So x equals 19 times sine 63. And the final step is to type that into the calculator. So that is 16.9, correct to 1 decimal place. Let's do it again. Question 3. Label the triangle. Across from the right angle is the hypotenuse. Across from the 24 degrees, this one's going to be the opposite. So the formula is sine theta equals opposite over hypotenuse. Then we substitute in theta is 24. Sine 24 degrees equals opposite is x over hypotenuse is 18. Third step is to times the 18 across. So 18 times sine 24 and type that into the calculator. Oops. So 7.3. Okay, question 4, do it again. So across from the right angle is the hypotenuse, across from the 70 is the opposite. Write the formula down. Sine theta equals opposite over hypotenuse. Substituting in, the theta is 70, so sine 70 equals, the opposite this time has the 10, so the 10 is on the top, and the hypotenuse is the x. Okay, now this is different from the other 3 questions that I have done, because in the other 3, the x was always on the top. When the x is on the bottom, to get it by itself, you would need to times that x across to this side, so it'd be over here, and then you want to divide the sine 70 back over to that side. Now, a shortcut, rather than doing all that timesing things around and dividing things around the place, is to simply switch places. The x and the sine 70 switch places. So that becomes x equals 10 over sine 70. And you type that in your calculator. So that is 10 over sine 70. Now when you're typing it in like a fraction like this, you do have to close that bracket or your calculator will give you an error. Press equals, and that's 10.6. Okay, so just remember, if the x is on the top, it means that you times the 2 things together like that. However, if the x is on the bottom, it means that you divide them. So there is actually 2 slightly different types of questions in here. So let's try question 5. We have got across from the right angle, that one's going to be the hypotenuse. Across from my 74 degrees is the opposite. And I write down my formula. Sine theta equals opposite over hypotenuse. Substitute in sine 74 equals opposite is 10 over hypotenuse, which is the x. So see the x on the bottom, which means we're going to switch places. X equals 10 over sine 74, and type it in your calculator. So that's 10.4. Okay, next one. Label the triangle. Cross from the 49 is the opposite. Cross from the right angle is the hypotenuse. Formula is sine theta equals opposite over hypotenuse. Substituting in, the theta is 49. Sine 49 equals, The opposite is 15, hypotenuse is x. Then because the x is on the bottom, we do a switch. X is going to be equal to 15 over sine 49 and type it into the calculator. So that is 19 point, we'll have to round up, 19.9. All right, 2 more down here to do at the bottom. You could pause the video and try these ones if you like, to see if you're doing it correctly. So for question 7, we've got hypotenuse here and opposite there. Write down the formula. Sine theta equals opposite over hypotenuse. Sub in. Sine 35 is the angle, opposite is 16, hypotenuse is x. So x is on the bottom again, so we switch places. X equals 16 over sine 35. So that's going to be fraction 16 over sine 35, which makes 27.9. And last one, we are going to type, or label our triangle. We've got opposite and hypotenuse, formula, then the substitution. So sine theta equals opposite is 13, hypotenuse is the x. Again, the x is on the bottom, so the x and the sine, oops, I didn't put my number in there, that should be a 41. The x and the sine 41 switch places, and we calculate. So that's 19.8. Okay, so there's some questions on the next page here for you to practice. All of them need to be rounded to 1 decimal place. There will be a mixture in there of questions that are timesing on the third line and some that are dividing on the third line. So just be careful, that's the tricky spot. So do that worksheet, please, and that's it for today.